Pistol shrimp and goby. The pistol shrimp is nearly blind. The goby is nearly defenseless. Together, they survive. The pistol shrimp digs and maintains a burrow in the sand, working constantly to keep it from collapsing. But it can barely see, which makes it easy prey above ground. So it shares the burrow with a goby fish. The goby has sharp eyesight and acts as the lookout. The shrimp keeps one antenna touching the goby at all times. When the goby spots a predator, it flicks its tail in a specific pattern. The shrimp feels the signal and instantly retreats into the burrow. In return, the goby gets a safe home it could never dig itself. The partnership is so reliable that some species spend their entire lives within centimeters of each other. The pistol shrimp also has another weapon. It can snap its claw at 100 kilometers per hour, generating a shock wave that stuns small fish. The blind digger and the watchful guardian survive together. Apart, neither lasts long. Clownfish and sea anemone. The sea anemone kills almost everything that touches it. The clownfish lives inside it on purpose. Anemone tentacles fire microscopic harpoons called nematocysts, injecting paralyzing venom into any fish that brushes past. Most species die within seconds, but the clownfish is coated in a thick mucus layer that the anemone reads as part of itself, so it never fires. The clownfish lives among the tentacles for life, immune to predators that would never dare follow. In return, the clownfish defends the anemone from butterfly fish, which feed on anemone tentacles. It chases them off with surprising aggression for a fish only 10 centimeters long. The clownfish also brings food. Scraps from its meals fall onto the anemone, which absorbs them. It even fans water with its fins, increasing oxygen flow across the anemone's surface. Both species can survive alone, but they live longer together. The most poisonous home in the reef is also the safest, if you know how to move inside it. Oxpecker and RHINO. The rhino weighs 2,300 kilograms and has skin 5 centimeters thick. It still needs help. Ticks, flies, and parasitic worms infest the folds of rhino skin, especially around the ears, eyes, and groin. The rhino can't reach them. Enter the oxpecker, a small bird that perches on rhino backs and feeds on parasites all day long. A single oxpecker can eat over 100 ticks in one feeding session. The rhino tolerates the bird because the relief is enormous. But the relationship is more complicated than it looks. Oxpeckers also peck at open wounds, drinking blood and sometimes preventing wounds from healing. Some scientists call them parasites in disguise. Still, oxpeckers serve as living alarm systems. They hiss loudly when predators or humans approach, giving the nearly blind rhino enough warning to charge. Black rhinos can run 55 kilometers per hour despite their bulk. The bird sees what the rhino cannot, and the rhino's mass protects the bird from everything else. Cleaner wrasse and reef fish. A 10-centimeter cleaner wrasse swims directly into the mouth of a moray eel. It leaves alive. Cleaner wrasses run cleaning stations on coral reefs, where larger fish line up voluntarily for parasite removal. The wrasse picks dead skin, mucus, and parasites off the fish's body, including the inside of the gills and mouth. Predators that would normally eat fish this size pose no threat, because the cleaner wrasse provides a service no one wants to lose. A single wrasse can service up to 2,000 clients per day. They perform a specific dance to advertise their availability and earn trust. Larger fish queue up, sometimes waiting their turn behind sharks, groupers, and parrotfish. When a wrasse cheats and bites healthy tissue instead of parasites, the client fish chases it off and refuses to return. Reputation matters. Studies show entire reef ecosystems decline when cleaner wrasses are removed, because parasites overwhelm fish that depended on the service. The smallest worker on the reef holds it together. Remora and shark. The remora doesn't swim. It hitchhikes. A remora has a flat suction disc on top of its head, evolved from a modified dorsal fin that lets it lock onto sharks, whales, sea turtles, and even the hulls of boats. The grip can hold against pulls of over 30 times the fish's body weight. Once attached, the remora travels for free, sometimes for thousands of kilometers. In return, the remora cleans parasites from the shark's skin, gills, and mouth. It eats scraps from every shark kill, picking up flesh fragments that drift away. It even cleans the shark's teeth. Sharks tolerate remoras because the service is genuinely useful, and remoras are too small and slippery to be worth eating. Some shark species have been observed allowing remoras to enter their mouths to clean between teeth, the same way a cleaner wrasse does. The fish that everyone calls a freeloader is actually a working passenger. The shark provides transport. The remora keeps the shark healthy. Hermit crab and sea anemone. A hermit crab living in an empty shell is vulnerable. Octopuses crack the shell. Fish drag the crab out. So some hermit crabs cheat. They carry sea anemones on their backs. The anemone attaches to the shell, extending venomous tentacles in every direction. Predators that approach get stung and retreat. The crab gains a 360-degree weapon system it could never grow on its own. In return, the anemone gets transport. Most anemones spend their entire lives stuck to one rock, eating only what drifts past. Riding on a hermit crab means access to new territory, fresh food, and constant water flow. When the crab eats, scraps fall directly to the anemone below. Some hermit crabs even pick up anemones and place them on their shells deliberately, gently coaxing the animal to attach. When the crab outgrows its shell and switches, it carefully transfers the anemone to the new home. Living armor that protects the crab and travels with it everywhere. Ant and aphid. Aphids produce honeydew, a sugar-rich liquid that ants will fight wars to protect. Aphids feed by piercing plant stems and drinking sap. The sap is so abundant in sugar that aphids excrete the excess as honeydew, often dripping it from their abdomens in steady streams. Ants drink the honeydew like cattle drink milk, so they farm the aphids. Ant colonies guard aphid herds aggressively, attacking ladybugs, lacewings, and other predators that try to eat them. The ants stroke the aphids with their antennae to stimulate honeydew release, the same way a farmer milks a cow. Some ant species carry aphids underground for the winter, keeping them warm and feeding them root sap until spring. Others clip aphid wings to prevent escape. A single ant colony can manage thousands of aphids, generating gallons of honeydew per season. The aphids gain protection from predators that would otherwise wipe them out. The ants gain a renewable food source. Livestock farming, invented millions of years before humans existed. Ant and acacia tree. The acacia tree pays its bodyguards in food and housing. Acacia trees in Africa and Central America grow hollow thorns up to 8 centimeters long, perfect for ant colonies to nest inside. The tree also produces specialized nectar at the base of its leaves and protein-rich nodules called Beltian bodies at the leaf tips. The ants eat both. In return, ant colonies, often Pseudomyrmex species, swarm anything that touches the tree. Giraffes, elephants, and beetles all get attacked by hundreds of stinging ants the moment they bite a leaf. The ants also clear competing vegetation around the tree, pruning seedlings and vines that might shade the acacia. Trees without resident ant colonies suffer significantly more herbivore damage and grow much slower. Some acacia species have evolved so fully into this partnership that they cannot survive without ants. Strip the colony away and the tree dies within months. The bodyguard relationship is so deep that the tree is essentially a living fortress, paid for in sugar. Boxer crab and anemone. The boxer crab carries a venomous anemone in each claw and waves them at predators. Also called pom-pom crabs, boxer crabs are tiny, only 2 to 3 centimeters across, and have weak claws that are useless for fighting. So they pick up small anemones, one in each claw, and hold them like living boxing gloves. When threatened, the crab waves the anemones at the attacker, delivering stings that drive off fish, octopuses, and larger crabs. The crab itself never lets go. If it loses an anemone, it will tear its remaining one in half so it can regrow into 2, restoring the matched pair. The anemone benefits too, gaining transport across the reef and access to food scraps from every meal the crab makes. Some boxer crabs carry the same anemones for years. Researchers have documented crabs stealing anemones from rivals during disputes. The smallest predator on the reef arms itself with weapons it cannot grow. Live armor in each claw, swung like flails. Crocodile and plover, myth versus reality. The story sounds incredible. A small bird walks into a crocodile's open mouth and picks meat from its teeth. The crocodile lets it live. This relationship was first written about by the Greek historian Herodotus over 2,400 years ago. The Egyptian plover became famous as the crocodile's dentist. The problem is, no modern scientist has ever filmed it happening. Despite decades of observation, there is no verified footage of an Egyptian plover cleaning a Nile crocodile's teeth. Some researchers believe Herodotus saw plovers feeding near crocodiles and assumed cleaning behavior. Others think the relationship may have once existed but has since vanished. What is real is that crocodiles do open their mouths on land to thermoregulate, releasing heat through evaporation. Birds sometimes pick parasites from crocodile skin, but the iconic image of a plover walking between rows of teeth remains unconfirmed. The most famous animal partnership in history may be a 2,000-year-old myth that everyone repeated without ever checking. Tarantula and humming frog. A massive tarantula and a tiny frog share a burrow on purpose. In the Amazon rainforest, the Colombian lesser black tarantula has a habit so unexpected that biologists initially refused to believe it. The spider keeps a small humming frog as a roommate. The tarantula could easily kill and eat the frog. Instead, it lets the frog live inside its burrow, sometimes even between its fangs. The frog earns its place by eating the ants and small insects that invade the burrow and would otherwise feed on the tarantula's eggs. The tarantula provides protection because no predator dares enter the home of a 25-centimeter spider with hollow fangs delivering paralytic venom. The frog gets a fortress. The spider gets pest control. Some tarantulas have been observed picking up the frog with their fangs, examining it, then placing it back down unharmed when they recognize the species. Two animals that should be predator and prey instead form one of the strangest alliances in the rainforest. Emperor shrimp and sea cucumber. The emperor shrimp rides on a sea cucumber for its entire adult life. Sea cucumbers crawl across the ocean floor at speeds of up to 5 meters per hour, vacuuming sand and digesting organic material. Most predators ignore them because their bodies contain toxic compounds called holothurin. The emperor shrimp, only 2 centimeters long, climbs onto a sea cucumber and refuses to leave. It clings to the cucumber's back, hitching a free ride across vast distances of seafloor that would take it weeks to cover alone. From this mobile platform, the shrimp picks tiny food particles stirred up by the cucumber's feeding. It also uses the cucumber's toxic skin as a shield. Predators that would normally eat the shrimp avoid the cucumber entirely. The cucumber doesn't seem to benefit or suffer. It's a one-sided relationship called commensalism, but the protection is real. A shrimp riding on a toxic tank, eating the dust kicked up by its host, safer than almost any free-swimming creature its size. Warthog and mongoose. A warthog lies down in the dirt and lets a pack of mongooses crawl over its body. Banded mongooses live in groups of 20 to 40 animals across the African savanna. They feed on insects, small reptiles, and parasites. Warthogs carry hundreds of ticks in their thick, bristly hide, especially in skin folds the warthog cannot scratch. So warthogs walk up to mongoose colonies and lie down. The mongooses swarm over them, picking ticks and biting fleas, sometimes for 20 minutes at a time. The warthog stays completely still, often closing its eyes in apparent comfort. The mongoose pack gets a buffet of high-protein parasites without having to hunt. The warthog gets parasite removal it could never achieve alone. Researchers in Uganda have documented this behavior repeatedly across multiple warthog and mongoose populations. The warthog doesn't fight, doesn't flinch, doesn't protect itself in any way. It chooses to be vulnerable because the relief is worth it. Service exchange between two species that have nothing else in common. Zebra and wildebeest. 2 million wildebeest and 200,000 zebras travel together across the Serengeti every year. Neither species could survive the migration alone. Zebras have excellent eyesight and pick out predators at long distances. Wildebeest have superior hearing and smell. Together, their senses cover gaps that either species would miss alone. They graze together too, consuming different parts of the same grass. Zebras eat the tough upper stems first, exposing the softer leaves below for wildebeest. The result is more food for both. During river crossings, the herd's massive numbers overwhelm crocodile predation. With over 2 million prey animals attempting to cross, individual losses become statistically negligible. Lions and hyenas struggle to single out targets in a stampede that wide. Even when one animal is taken, the chaos of motion confuses predators long enough for thousands more to escape. The wildebeest provides numbers. The zebra provides vigilance. Predators that would devastate either species alone face a moving wall of cooperation that crosses 1,800 kilometers each year. Dolphin and human. In Laguna, Brazil, dolphins have herded fish toward fishermen for over 140 years. The fishermen stand in waist-deep water with throw nets, waiting. Dolphins drive schools of mullet towards shore, then perform a specific signal, often a sudden head slap or a sharp dive, indicating the exact moment to throw the net. The fishermen who can read the signal catch dramatically more fish than those fishing alone. The dolphins benefit too. The thrown net disorients the school, allowing dolphins to pick off stragglers and stunned fish that would normally escape. The behavior is taught from mother dolphins to calves and from older fishermen to younger ones. Both species pass the partnership down through generations. Genetic studies show that cooperating dolphins have higher survival rates than non-cooperating dolphins in the same waters. The most extraordinary thing is what this partnership represents. Two species, separated by more than 90 million years of evolution, communicating across the surface of the water to hunt as one team.